Next, I'd like to introduce the session on using augmented reality as an urban design tool. I think your work has been alluded to so far, so I'd like to present Dr. Gun Lee. Gun is a postdoctoral fellow. He's researching interaction with and visualization methods for augmented reality and immersive 3D environments. Before joining the University of Canterbury, he worked at ETRI in Korea as a senior researcher, where he developed VR and AR systems for industrial applications. So I'd like to welcome you to
Thank you, George. So our project is Project 4.52, using augmented reality as an urban design tool. Our project leader is Professor Mark Billinghurst. Fortunately, he was not able to make this conference, so I'm presenting this project on behalf of him. So in Christchurch, last year in February, we had a big earthquake that hit the city, and many of the buildings has been taken down and still in the process of demolition. And as you can see here from a map that shows each quake on the Google map, you can see how many of those quakes has been happening and how many part of the city has been affected. So as the cleaning up process will end, we will start to plan the new design of the new city. And many of the urban planning ends up with a visualization, which is one of the major research areas of HitLab at University of Canterbury. And many visualization tries to visualize the new urban, new building designs or layouts in type of this kind of exocentric viewpoint. But unfortunately, this kind of visualization doesn't shows, it's difficult how to imagine how actually the city will look like, or how it will look like when you are standing in front of those buildings. There are some other types of visualizations like this, where you take a photograph and overlay with graphics on top of it, so that you could show a little bit how would it look like and how does it, and compare with how does it look like at the moment. But unfortunately, since it's a 2D graphic, you can not really tell how the 3D spatial configuration of the new design will look. So to fill in that gap, we have been trying to use a technology called augmented reality, which is a kind of human interface technology that shows computer graphics image on top of live video. So let me show you a video. Short video clip that shows the concept of augmented reality. So as you can see here, a person is looking at a kind of booklet that doesn't has nothing much other than squares on it, and he's holding a kind of pedal. He looks a little bit out of mind because he's putting this pedal in the air. But it's a little bit easier to understand what he's doing if we look from his viewpoint, which shows what he's actually looking at. So this video clip is the same process. I mean, from his viewpoint, as you can see here, you can see 3D models which represents the furnitures are overlaid on top of real environments, so that you could actually scoop them up and place it, push it away, and try to lay out a kind of virtual model of the interior design you're working on. So this is a typical example of augmented reality technology we have been researching at the HitLab. So we were thinking of this kind of technology might be useful for visualizing new urban designs. So augmented reality combines real and virtual images. So you can see both real world and the virtual 3D models at the same time. Not only showing them side by side, it's actually the 3D models are registered in a 3D spatial environment. So then you can see as if those 3D models are fixed in the real space. And different from Hollywood movies, which also combines computer graphics and real images. Augmented reality is processed in real time, which means you can interact with it, you can change, and you can modify the design on the fly. So it's more like looking through the it's working more like a filter between you and the real environment and augmenting it with virtual information. And as as shown in the video clip I've shown you before, there has been a couple of researchers trying to develop AR interfaces for urban designs as well, but most of them were actually done as a desktop interface, which shows a virtual 3D model on top of a kind of disk, and you can interact and manipulate the virtual objects. But many of the system doesn't really show in the egocentric view or first-person viewpoint to show how the new city design would look like. So as the technology has been advancing, the AR systems were not only restricted to desktop or indoor environments, but has moved into mobile augmented reality, mobile augmented reality, which has been using different types of sensors technologies. Like this is a picture from like 5 or 6 years ago. Our director, Professor Mark Billinghurst, is wearing this backpack which has a laptop in it, and also he's wearing a hat that has a camera in front of it and a small display that you can see through this camera, and a GPS sensor and other orientation sensors embedded in glass, so that in his viewpoint he might see some graphics overlaid on top of the real environment. So this was like 5 or 6 years ago. These days we don't need any laptops on your backpack anymore, since the mobile devices has been developed quite a lot, and since the smartphone has been introduced to the consumer market, it has been much more easier to implement augmented reality system and make it available for the general public. So we are trying to use this mobile augmented reality technology as an urban design tool, especially for visualization tool, so that you could share the vision of the new design with others and also see actually what it would look like as if it's built on that side. So the concept is simple. You can go to the real environment where the construction is happening, and if you hold your mobile device, whether a smartphone or a tablet, you can see and start the camera, and you will see the real environment through the camera and on the screen. And not only seeing that real environment through the camera, you will be able to see the new design or 3D model of that building that has going to be built there or was there. So we have been developing a prototype software, and especially we've tried to build an application around the earthquake event we had in Christchurch. So we tried to visualize the 3D models of those buildings that are unfortunately demolished during the earthquake times. For instance, this is a old library, which is a heritage building, and unfortunately this has been taken down due to the earthquake. And as you can see here, if you hold this device and run the augmented reality software, then you will be able to see the 3D model of that old library, which was as if it was before the earthquake. So let me show you a short video clip showing how it actually looks like. So as you can see here, that's the actual site, and this is a 3D model of that building, still showing the real environment as a background. You can see that building on the background is actually the real building that's standing there, and still demolition is going on. So we have been trying to build more information around this augmented reality piece, so that we could kind of help people keep their memory about the Christchurch city and build some contribution to this local community. And we have been adding contents like pictures of buildings and historical stories or panoramic images around it, and of course the augmented reality piece is in there so that for the user side, if he's holding this device, holding his own phone with our software, he'll be able to actually walk around the city and see the buildings, how they were before the earthquake. So we have a prototype software running, and it's currently running on Android platform. So if you have one of those Android devices, then you'll be able to actually download our software freely from Android market. And if you come to our booth, Project 4.52, I can point you to how to download or install the software. And I also have a tablet that runs this software, so I can show you the demo how the software looks like and feels. So as a part of developing that application software, we have been also developing the software framework for general applications so that it will be easily applied to other projects as well. So currently we are providing functions like 3D visualization and tracking of the user position and orientation based on the sensors on your mobile device. And also it's built in a component-based design, so it's easy to customize for different types of applications. So our next step is to add some more functionality that directly relates to urban design visualization, like switching between different types of design plans, or switching between the past, present, and future, like time traveling, and also building support for social interaction between users so that they could share their views on the new design of the city and sort of things. So, conclusion, augmented reality seems to be allows geospatial visualization in place, showing 3D models in the real environment. And hardware and software platforms are widely available, especially on mobile devices. These days, it has been widely available for consumer market as well. And there are many possible commercial possibilities, especially in urban design applications or tourism or heritage. And still, there are important research problems, like we need more reliable tracking. We are looking into improve tracking and registration using computer vision technology. And also, we'll try to enhance more user experience around researching more usability studies. So thank you. If you would like to have more information, you can mail me or Professor Mark Billinghurst, and this is our website, so please visit, and you would be able to see some video clips and more information around it. Thank you very much.